for our unit on circles, the first thing we need to do is be able to identify all the parts of a circle. I'm sure the one you're most familiar with is the radius. Now the radius is this line here that starts at the center of the circle and goes to the outer edge. And you notice that's only from the center to the outer edge, which is actually half of this line that goes all the way through the center from end to end, and we call that the diameter. Okay, so the radius is half the diameter. This next line here, this dark line here, is called a chord. Okay, and you'll notice a chord is different from a diameter, as the chord does not go through the center of the circle. The only two parts of the circle that radiate from the center or go through the center are the radius and the diameter. This green portion here is what we call a segment. We're not really going to be working with that too much, so I wouldn't really be too concerned about that. But good to know. And then, and this little darkened portion here it's a portion of the outer edge of the circle, which we call an arc. Okay. Now, on our second circle, obviously, the very middle is called the center. Notice how this green shaded region is different from the other circle. This shaded region is called a sector, and it's special because it radiates from the center of the circle, and it's made up by two radii. Okay, so the sector actually shades in a portion of the circle from the center versus the segment, which is just created from a chord. You notice that this line here refers to the outer edge all the way around the circle, which we call, of course, the circumference. And then this line here is special. It's called what we call a tangent. And a tangent line touches the circle at one distinct individual point. And we're going to talk about that in a little bit and why that's significant. Okay, so those are our parts of the circle. The ones that we're going to be focusing most on are the arc, radius and diameter, obviously, the sector, and the circumference are going to be the most important things that we're going to see and use most often. Okay. Here we're going to see if we can identify a few parts. So here we have find the following measurements of AO, BO, and then AC, which is the whole thing. So if you'll notice, DO, BO, AO, they're all radius, or radii is how we say the plural. So these are they're all 3 centimeters. Okay? Any line that comes from the center to the outer edge is going to have the same length. Now, if you notice, AC is formed by 2 radii, and that is actually a diameter. And you'll notice how the diameter is double the radius. So AC is actually 6 centimeters. Now with the radius, we can calculate the circumference and the area. Now on your MCAS reference sheet, you will see that the circumference, the formula is 2 pi r, or just pi times the diameter. And the area is pi r squared. Okay, so in both cases we need the radius. The circumference, the reason you can use 2 pi r or pi times the diameter is because, excuse the dogs, because the radius is made up of, since the diameter is created by 2 radii, that's why we can use in the formula either 2r or just the diameter. It's going to be the same measurement, whether I do 2 times the radius or just the diameter, the full length of the diameter. We both, in either case, I get 6. And then times pi. Now remember, pi can be abbreviated by using 3.14. So this would be 6 times 3.14, or you can, on your calculator, you can do 6 times the pi button, and we will get 18.8 as my circumference. Okay, so all we're doing is multiplying. We did 2 times the radius, 2 times 3, which is the radius, or took the full length of the diameter, which is 6, and multiplied it times pi, or 3.14. And so we got our circumference, which is the measurement all the way around the circle, to be 18.8 centimeters. Now, to find the area, so that's the space inside the circle, my formula is pi r squared. So my radius is 3, and remember the order of operations dictates that I square the radius first before I can multiply. So 3 squared is 9, so 9 pi. And when I multiply 9 times pi, or 3.14, I get an area of 28.27, or if you wanted to round that up to 28.3 centimeters squared, because it's area, so it would be squared. Okay, so those are the 2 primary formulas that we're going to use with circles, circumference and area, which hopefully are familiar to you and you've seen those before. Okay, next, we want to talk a little bit about the degrees in a circle. Okay, so for starters, circle has 360 degrees. And question number 4 asks, how many degrees does a semicircle have? Now, a semicircle is literally half the circle. Okay, so if the circle has a total of 360, half of that would be 180 degrees. So whether I ADC or ABC, each are half, or 180 degrees. Number 5 asks, what is an arc of a circle? Well, an arc is a portion or a part of the circumference. Okay, and if I erase my red here, So AB is a portion of the circumference, and we would write that as arc AB with a little half circle over top. BC is also a portion of the circle, so this would be arc BC. So you get the idea of what an arc is. Let me take that off because we're going to use that in just a second. Number 6, draw a tangent line that intersects with point B. So remember, a tangent line touches the circle at exactly a single point. So that single point is going to be B. So my tangent line is literally going to just touch the outside. Okay, that is my tangent line right here. Okay, that's my blue line. You don't have to write that on your paper, obviously. How many degrees is the angle formed by a tangent line and the radius BO? So here we have my tangent line B, and BO is my radius. Now, if you look at this, you might be able to see if it actually creates a right angle. Any tangent line, I mean, I could draw a tangent line at point D, I can draw one at point C, I can draw one at point A. It doesn't matter. But if it intersects with a radius, that angle is going to form a 90-degree or a right angle, always, okay? Any tangent line and a radius will always give you a 90-degree angle, okay? Number 8 says to use colored pencils and highlight arc AB in red. Okay, so AB is literally just from here to here. Okay, it's that portion of the circle between those 2 points. Then it asks us to draw AD in blue. So AD is from this point to this point. And then arc BCD in orange. Well, I don't have orange. I'll use green. But BCD. Now I have 3 letters there because from B to D, I can either go clockwise or I can go counterclockwise to get to D. So to determine whether I'm going clockwise or counterclockwise, we need that center letter in there to tell me which direction I'm going in. So in this case, BCD would be this. Okay, so you'll always, so if there's ever a question as to whether or not you should go clockwise or counterclockwise in terms of highlighting an arc, look at that center letter. That center letter will tell you which direction you should go in. Okay. If arc ADC represents half the circle, how many degrees is arc ADC? Okay, so let me get another color here. Okay, so ADC, you'll notice they said it's half the circle. And we know it's half because the diameter cuts it in half. And it represents a semicircle. Well, half the circle we mentioned earlier was 180 degrees. And if you'll notice, that diameter, although it might be inside a circle, but we have a straight angle, which is 180 degrees. Okay. Number 10, if arc CD represents a quarter of the circle. Kind of limited on my colors here. I guess I'll go with black. CD represents a quarter of the circle, or half of the 180. And ignore Molly because she's whining. So if I take 360 and I divide it by 4, that's going to give me 90. So arc CD happens to be 90 degrees. And ironically, that radius with the diameter does form a 90-degree angle. Okay. If angle COD equals 90 degrees, so COD, which I drew, is 90 degrees. Based on your answer to question 10, what is the relationship between an angle formed at the center of the circle and its intercepted arc? So what we're trying to get at here is that you notice how the diameter being yellow, we know it's half the circle, which is 180 degrees. And it does form that 180 degree straight angle there. And COD is 90 degrees, and that represents a quarter of the circle, which is also 90 degrees. Okay, so what I want, the relationship here is that whatever the angle is, so let's say this was 25 degrees, whatever the angle is formed at the center of the circle, that arc will also be the same value, okay? And this is what we call a central angle, okay? Central angles are always equal to the measure of the arc in degrees. Okay, they're exactly the same because we're just cutting up the circle and forming an angle that is equivalent to a portion of the circle itself. So all central angles will have the same measure. So COD is 90 degrees, so that means that arc CD is 90 degrees. So they're exactly the same. So the relationship between the angle formed at the center of the circle and its intercepted arc, they're exactly the same. They're equal.